So let's try to understand the brute force approach for this particular solution. Okay, so there's a number of ways from which we can solve this. We can iterate from all of the hats and find the valid permutation. We can iterate from all of the student and find a valid permutation. Right, so let's try to do this with hat map. So we'll be try to iterate through all the possible combination of hats, and from that we just count the valid combination that will add up to our answer. So for that we need to create a hat map first. How will we creating the hat map? We'll say like this particular hat is in preference list of which particular student. So hat 1 is in preference list of only student 1. So hat 2 is in preference list of only student 1. Hat 3 is in preference list of 1 and 2. Similarly, hat 4 is in preference list of 2, 5, 2 and 6. Empty was 2, 40. It is also empty, right? So this is our hat maps look like, right? Now we want to iterate it in such a way that we will able to find the valid answer, right? So let's start with 1, hat number 1. So we need to find all the valid combination, right? Okay, so we start from hat number 1, right? We also maintain the list of the student which is already done. So suppose we are at number 1, we say let's give it to student 1. Okay, so we have the list. Okay, let's write it here. Hat 1 to student 1, and this is the list which basically tell us like what is, you know, whosoever is already wear hat. So S1 is done. Now we jump to hat 2, and here we can see in our list there is student 1. So from the list we check, you know, this is, you can see visited list. So from our visited list we check that S1 is already done. Is there any other student that we can iterate in as hat 2? No one is there, so we say this is not allowed. Similarly, we go to hat number 3, and first we got student 1. Student 1 is already done, so it's not allowed. So we have other student 2. Is it possible? Yeah, it's possible. So we say now S2 is also done, right? Okay, so we get whensoever the count of the visited list will equals to the n equals to 2, it means like all the student has wear hat, so it's our answer. So we say S2 is also done and our list size will be equals to 2. That's why this is our answer. So here we can say our answer will be hat number 1, 3. So this is one combination, right? Now we need to find all the possible combinations. So okay, so we are at 1, 3 is done. So let's go to hat 4 now. So in 4, again we are at same position, right? S1 is done. So we just ignore 3, like this already add to our answer. So we are finding next combination. So S1 is done. Yeah, S1 is done. So I'm writing the possible answer, right? So now we are at hat 4. So we find like student 2 is there. Is that done? No, it's not done. So we say it's done. Now visited list size again become 2. Then we can say this is our answer again. 1, 4. Is there any other person that we can iterate? No, nothing is there. So we'll jump to the next hat. Hat number 5. Similarly, we can say like, you know, again, is S2 is there, like, is that already listed? No, it's not. And again, we jump here. We say our answer is hat 1.5, right? So from 1, we have 3 possible answers, 3, 4, 5. This is from 1. We do this for all of them, right? So we are at hat number 2. again we created a visited list, which basically tell us like, whatsoever is done right now. At number 2, we say S1 is done. Okay, so S1 is done. So from here, similarly we got 3, 4 and 5. So from 2, 3 to 4 and 2, 5 is our answer, right? Similarly as we done, the earlier one. So when we are at hat number 3, so first we got 1, S1, right? Now we got S1, now we jump to the next, hat 4. Is this possible? Like to create a combination? Yeah, it is. It will give us S2. Now we say list is S2. So at each and every point we need this visited list. That is, that we are maintaining to get to know like whatsoever is already visited with this particular run, right? So each point has their unique visited list, right? So keep this in mind, like each point has their unique visited list. Okay. So similarly with hat number 3, the answer would be 3, 4 and 3, 5. Right. Now keep it in mind, hat 3 has 2 options, right? S1 is there and S2 is also there. Now we choose S2. Now our listed list become S2. Right. Now we jump to hat 4. We are already proceeding to the next number, because if we proceed to the previous one, it's a repeatancy. Like 2 will also, if we proceed to last one, the answer will be 2, 1. That's already done in here, right? So that's why we are not proceeding backwards. We are only proceeding forward. So S2 is there, so we can't do it. At number 5, S2 is there, we can't do it. So that's all with 3. Like only 2 are possible answer. Similarly with 4, we have S2, we can't do it, like this is also S2. Similarly with 5, we can't do anything. So there is no other answer. So how many answers? 1, 2, 3, 4, 5, 6, 7, 8. So that's why the answer is 8 here, right? So what we are doing, we are just iterating through all the possible combination. We are maintaining the visited list, whatsoever is done right now, and from that visited list we are checking, we are updating that visited list in every go, and we are checking whenever the size of the visited list will equals to n, we say this is our answer. We are not moving forward after that, right? We are just going for the next permutation. Okay, so this is our answer. I think it makes sense to you.